Welcome back to Connect and Transform. In this video, I'm going to talk about how I choose to design circuit boards and how I choose to create the files that I submit to the manufacturers. If you're a real engineer, you're not going to want to watch this video because I do it my own way that allows me the highest degree of control and the highest degree of flexibility, but it also requires the highest degree of initial commitment and you waste some time. But basically, I use the PCB design programs as a very fancy version of Paint or Photoshop. And so like here, for example, this is the older project that I mentioned in my last video. The blue is the copper traces on the bottom. The red is the copper traces on the top. So if I hide those two, for example, then it gets to be a little bit more reasonable. If you look at the top left, you can see that I'm not using that many different layers. Like I mentioned, the red and the blue are the top and bottom traces, the copper that connect point A and B. The vias, that's basically a drill hole that has metal inside the center of the hole, and it connects the top and bottom layer at that point, shown in green here on the board. The dimension layer is useful, required by some manufacturers to define the outer edge of the board. The top and bottom silk screen, that would be all the visual and text components that you can read. So for example, I just have some simple lines to give a general outline of the components, and I have some text to describe the component. And then the masking layers, top and bottom mask, that's basically saying where should the protective masking layers not be. In other words, where should the bare metal be so that we can solder the components to the board? So that's the purpose of those. And then you have drills and holes. So I've turned off everything on the bottom of the board, and so now we're only seeing the layers that affect the top of the board. So I'll briefly give an example of how I use this type of program. So if I scroll in here to this 100K resistor, so if I copy or if I select this area here, basically I have some text to tell me what it is. I have a couple lines here just to show that these two pads are part of the same component. And then we have a red rectangle, which is denoting the actual metal, the copper area, and then the black or gray hatched area, that's showing everywhere that the protective mask should not be. So everywhere that should be exposed. So real quick, up here in the top left, I'm going to select the copy function and then the select function. I'm going to select this, right click, copy group, and then based on the precision of my grid, that helps determine where I can actually position this. So for example, if I go up here top left, view grid, so we can see that right now I'm on a 0.1 inch grid. Let me just delete that real quick and then delete that. So if I select this, right click, copy group, I can drop this at any interval of 0.1 inches and it should be exactly in line. And so that helps me keep things symmetrical. It helps me keep things spaced out in an appropriate way. So that's an overview of how I actually use the tool. Is I build these things one time. So like I built the definition of this particular resistor, which I believe is a 0603 resistor, which has a very particular pad size and pad spacing. I built it once and I just copy it and move it around. And then I might select the wire tool and then either the top or bottom trace. Now it's going to be locked to the grid, so it's not going to actually select the resistor. But the idea would be I would take one half of the resistor, connect it to something, take the other half of the resistor, connect it to something else, and then that's it. That's how I use the tool. So if we look at the old project, the bottom center of the board, I had a USB connector here, but this was a long time ago. This particular connector was not USB-C. So I need to basically produce a picture of the USB-C component. So let's go over to here. I happened to look on Mouser.com. There's a lot of different electronics websites, but I looked for USB connectors. I found the ones with the least number of contacts that actually supported data transmission, because the fewer contacts there are, the easier it's going to be to solder. And then basically I just sorted by price, and I looked around for ones that were in stock that also had at least a few thousand, and I just kind of scrolled, and there's one with tens of thousands, and it's a fairly reasonable cost, even in quantities of one. So then I investigated that one. So this is the product page for this particular USB-C connector. I scrolled down to the bottom. You have technical drawings, and you can get CAD models. So I went over here to the CAD model, and I said download for Eagle, because that is the PCB tool that I happen to be using. And then here in Eagle, I went to Library, Use, and then I navigated to the downloaded file. And then now I can go here to the Add tool. But first, I'm going to change the grid to be a little bit more fine. So instead of 0.1, let's cut that in half. And then let's cut that in half again. Let's cut that in half again. Okay. And then I'm going to say add. And then I've navigated to this library that I just imported, the USB 4105. And then I'm selecting the component. I'm going to say OK. And so this is the model that I just downloaded. Now I want to try and get it lined up side to side. I'm realizing now I probably should not have made the grid so fine quite yet. But let me see. I think that's right. So I'm going to drop that on the grid, and we'll investigate. So real quick, I'm just going to draw a blue line from the dead center of the other connector. Okay. And we can see that it does go right through the dead center of that little cross indicator there. So we do know that this is dead center on our board. And that just makes it easier when we're changing grid sizes, that it'll probably be more compatible. Okay, now the next thing I'm going to do, I'm going to right click on this, go to Properties, because we're going to draw an outline for ourselves. So this is on the top 21 top silkscreen layer, and it's 0.012 in width. Okay, so I'm going to select my line tool over here on the right. I'm going to switch the layer to 21 top silkscreen. I'm going to change the width to 0.012, and I'll go back to my line tool. So now I should be able to approximate. It doesn't matter that we're exact or not. I just want to approximate the general polygon. Now up here, maybe I'll just go, well, I don't want it crossing over the copper, although I do believe that the copper would take precedence anyway, so I don't think it would hurt anything, but I'm just going to do that. So once the piece is soldered on the board, we might see this little bit of rectangle identifier here, but it doesn't really matter. And I'm also not going to copy the pin 1 notation here, because you can't rotate the thing. It's only going to have one orientation because it's a surface mount device and it's not rotationally symmetric. So I'm not going to bother with that. So now I just have to do the stop mask and the copper pads and the vias and the drills. I'm going to look at the properties here. Okay, so that's 0.035 drill size. Okay, I guess I'll just copy that for now, and we'll get it close. I think I'm going to have to make my grid twice as fine to get these drills placed properly. But I'm noticing that that's a pretty large drill size. So I'm just going to shrink it by 1, and let's see if that's close. Yeah, it's still bigger, but it's close. So now I'm going to go up here, View Grid, and let's make this smaller. So half of that would be that. Okay, so it's not going to be exact with this grid measurement. That's probably okay. Maybe I'll see. Oh, I'm also noticing that this particular drill is not exactly lined up with the grid. Okay, now it is lined up with the grid. So that's a little bit better. So I'll copy this over to here as well. So again, not perfect, but close enough for our purpose. Now let me remind myself of what layer this is, for example. So this is top mask. So top mask. And instead of doing individual top masks, I could probably just do one, but I'm noticing that the grid isn't lining up with these very well, so I'm going to have to shrink the grid yet again. So half of 625, that would be 312.5, which would be that. And it's still not quite lining up. Let me see if I can shrink the grid one more time. Let's see, view grid. Okay, so what is half of 3125? That would be 15,062.5. Okay. Now I think we're close enough that it just doesn't matter if we're off. I doubt the precision of the manufacturer is even anywhere close to this. So, okay, I've just made one giant rectangular mask polygon over the entire model for all those pins. Now I want to do the same thing for these. And again, it doesn't have to be exact. It doesn't even have to be the same shape necessarily. It's just got to be close. And I'm going to copy that and use it on the other side. That's interesting that that one must have just lined up differently. Oh, maybe I screwed up. I'm going to make a second polygon. I'm just going to purposely shift it down by 1, but I'm going to make it a little bit wider, and then we'll delete that one, and then I'm going to move this one to there and copy it to the other side. So you can tell this is a lot of work, but I only have to do this once and then it's done. And we're almost done with our work here. So let me estimate this side as well. I think that's reasonable. And we'll copy this over to here. Okay, so now I think we just need our vias and then finally our top layer copper pads. Let me just place this via out here. I'm going to change it to round. And I don't think the width matters because it's going to be surrounded by top copper anyway. But let me just pick something. That didn't seem to do anything. Okay, well, I guess it did. That looks pretty close to my eye. I guess it could be a little bit bigger. Again, I don't think this matters at all. Okay. And then as far as the drill size, it looks pretty close to me. So I'm just going to drop it there, and then I'm going to copy that. And I'll just drop it pretty close, and then we'll copy that again. That one didn't line up quite as well. And then we'll drop that. Okay, so now all we need to do is I'm going to select rectangle tool, change that to the red top mask. So now we just need to create our polygons, and they just need to be close. They don't need to be exact. As long as they're not too close that they're actually touching each other, it should be fine. And in fact, I may just copy these so they're all the same size. Okay, so we're getting close. All right, I think all we have left to do is the 4 red pads over here. So I'm trying to visually line that up as best I can. That's pretty close. I might make it, I'm going to move it over like that. Okay, and then I'll copy that. We'll use the same size on the other side, like that. And then possibly just use the same size again. Actually, maybe not. I don't think it would hurt anything, but I don't think it's necessary to use the same size. That's close enough. All right, so we should be done as soon as I place this piece. So now if I scroll out, I should be able to just delete this. And now what you see is basically the Paint or Photoshop version of the exact same thing. And let me change the grid back to something like 0.025. So we have a much rougher grid. But yeah, so now with this saved in the file, I can copy it. Actually, let me do it this way. So now I can say copy group, and now I can place another USB-C connector there, or I can place it there, for example. So you can kind of get an idea for its relative size to the non-USB-C connector, the difference in where the drill holes are, and especially the difference in the spacing of the pads. So these pads on the USB-C connector are much, much tighter together, and I hope that will be okay. I believe they are 0.5 millimeter apart, which is pretty tight. But there you have it. So we've just added that model. So I've saved this copy of the board, and we'll modify this file as we build out our PCB for the project. But now I've got this model built in my Paint/Photoshop paradigm so that I can copy this into other projects. Now, I will probably use it in at least one project before I copy this model out, because I might need to make some tweaks. I might need to change drill sizes. I might need to slightly modify the positioning, but we were basically just tracing over the model that we downloaded, so it should be pretty close. So there you have it. That's how I generate PCBs, is basically just use it like Paint or Photoshop, and then I'll export the files that are needed by the manufacturer. I'll go over that in another video, probably as we progress in the project and get to that point. But maybe this gives you a little bit of exposure, even if it's bad exposure, to the amount of flexibility that you can have when you're designing a circuit board, because you're literally left with full control if you're using it like Paint or Photoshop. So thanks for watching.